Let's have a look at the example. Suppose you wish to compare a new method of teaching reading to slow learners with the current standard method. You decide to base your comparison on the results of a reading test given at the end of a learning period of 6 months. Of a random sample of 22 slow learners, 10 are taught by the new method and 12 are taught by the standard method. The mean reading scores of those taught by the new method is 76.4 with standard deviation of 5.83, and the mean reading scores of those taught by the standard method is 72.3 with standard deviation of 6.34. Estimate the true mean difference between the test scores for the new method and the standard method. Use a 95% confidence interval. So using this description, we can get the following information. So we have two sample means. The first sample is 76.4 and the second sample mean is 72.3. We also know two sample standard deviations. The standard deviation in the first sample is 5.83 and in the second sample it is equal to 6.34. We also know sample sizes. The first sample includes 10 people and the second sample includes 12 people. We are asked to use the significance level. We are asked to construct 95% confidence interval. That means that the significance level is 100 minus 95, so 5% or 0.05. Based on the information above, we can calculate the degrees of freedom, which is n1 plus n2 minus 2, so 10 plus 12 minus 2 will be 20. And knowing the degrees of freedom and the significance level, we can get the critical t-value at the significance level of alpha over 2, so 2.5%. And if we use the table, we will see that the value that corresponds to 2.5% and 20 degrees of freedom is 2.086. So when we substitute everything into the formulas, we will get the following. So first we need to calculate SP squared. And so 10 is n1, 5.83 is the standard deviation from the first sample, 12 is the sample size of the second sample, and 6.36, this is the standard deviation in the second sample, 10 sample size 1, 12 sample size 2, and we get that SP squared is equal to 37.45. And then after we've got SP squared, we can construct the confidence interval. So x1 minus x2, this is the difference between two samples means, 76.4 minus 72.3 plus minus the critical t-value, which we have found in the table to be equal to 2.086, and then the square root under which we put SP squared is 37.45 multiplied by the sum of 1 over n1, so 1 over 10 plus 1 over n2, so 1 over 12, and in the end we get the following confidence interval. So the lower boundary is negative 1.4 and the upper boundary is 9.54. And it can be interpreted in the following way. We are 95% confident that the difference in mean test scores between using the new method of teaching and using the standard method falls into the interval from 1.4 and to 9.54. So the true difference between two population means with 95% confidence lies between these two values. And let's continue working with the second example. Let's now determine if the new method is more effective than the standard method. And to do that, we will conduct the test at 5% level of significance. So as always, we start by formulating the null and alternative hypothesis. So the null hypothesis is that the true population means are the same, so that the teaching methods are the same. And the alternative hypothesis is that the first population mean is higher than the second. So the first method of teaching, so the new method, is more effective than the standard method. So mu1 minus mu2 is higher than 0. We use 5% significance level. Degrees of freedom is calculated as n1 plus n2 minus 2, which is 20. And from the alternative hypothesis, we know that this is a positive one-tailed test. So using the table, we need to get the critical t-value at 5% level of significance for 20 degrees of freedom, and it will be equal to 1.72. In the next step, we estimate the T statistic. So x1 minus x2, 76.4 minus 72.3. These zeros, this is the value from the null hypothesis, and in our case it is 0. Then sp squared is 37.45. We got it in the previous step. N1 is 10 and N2 is 12. So we get the t value of 1.56. And the last step would be to compare this estimated t value with the critical t value of 1.72. And we can see that 1.56 is definitely lower than 1.72. Therefore, we cannot reject the null hypothesis, which means that at 5% level of significance, there is insufficient evidence to conclude that the new method of teaching is more effective than the standard method. So we accept the null hypothesis that the two population means are the same, which is the same as saying that the two methods are the same in terms of their effectiveness in teaching how to read.